Hello, Fitzies. Today we're going to be talking about 7.4, Evaluate Logarithms. Evaluate Logarithms. Logarithms, kind of a new thing for most, if not all of us. The definition of a logarithm with base b is the following. It says, let b and y be positive numbers with b not equal to 1. The logarithm y with base b is denoted as log base b of y. That's how we're going to say it. So we're not going to say logarithm every single time. We'll mostly just say log base b of y. Log base b of y. And it is defined as the following. So log base b of y is equal to x if and only if b to the x equals y. Now here's the thing, what you're used to is b to the x, like some number raised to some power. What we're talking about with logarithms is the inverse of that. So if you think back to your wonderful elementary days, you will remember that first you learned addition. Great, I have that mastered. And then you learned about its inverse, which is subtraction. Then you learned about multiplication, and you're like feeling good about that. And then after that, you learned about its inverse, which was division. Division at that point in your life was a completely new concept, completely different, but you knew its opposite and you were really well acquainted with that. Same thing with logarithms. New for most of us, but we're familiar with its inverse, which is b to the x equals y. So if you have, for example, once I turn my handy dandy pen on, if you were to have log base b of y is equal to x. Let's talk about this if and only if for just 1 minute. The opposite I told you there, the inverse rather, of b to the x is log. So if I wanted to get rid of this to get the y by itself, what I would do is base b both sides. Really what we're doing, it's called exponentiate. It's your other new word of the day, exponentiate. You can say it with me if you don't think people will look at you and laugh because you're watching this on video. But the word of the day is exponentiate. That means this is now a base and this becomes an exponent. So what we had as regular numbers are now exponents. And when that happens, these cancel out because they're inverses. And I just have y is equal to b to the x. See how this x is now an exponent. Why? Because we exponentiated both sides. Okay, the expression log base b of y is read as log base b of y. I can't even say it any other way. And I don't want you to say it. I don't want you to say log by. Log base b of y. Another thing, if you wanted to, if you weren't worried about people judging you, you can say it out loud. Log base b of y. Okay, so rewrite the equation in exponential form. In order to do that, beautiful people, we are going to exponentiate. So if you're looking at this, if you want to read it to yourselves, it's log base 5 of 125 equals 3. So the base in this instance, or in this case, is 5. The base is 5, so when I exponentiate, my base is 5. And so these cancel out. And I have 125 is equal to, this 3 was a regular number, now it's exponential, it's an exponent. Why? Because we exponentiated. This is written now in exponential form, and that is your final answer. I'm going to put a box around it because I know some of you like that. 6. Okay, number 2. Same thing, beautiful people. You're going to feel like this should be harder, but it's really not. I have log base 1/3 of 3 is equal to -1. And again, I am going to exponentiate both sides. What's the base? Well, we said the base was 1/3. So my base is going to be 1/3. My base is going to be 1/3. I do like to put in parentheses just because it's a fraction. So these cancel out the same way that they did here. And I have 3 is equal to 1/3 to the -1. And for those of us that don't remember, a couple chapters ago, again, this -1 means the reciprocal. So just to prove it to you all, 1/3 to the -1. If you distribute the exponent, it's like 1, excuse me, 1 to the -1 over 3 to the -1. And remember, for negative exponents, you're supposed to flip them. So this will go to the bottom. This will go to the top, which is equal to just 3. This is a true statement, and that's how I know for sure that I did it correctly. So if you want to, if you're feeling pretty good about this, go ahead and press pause. You can just check your answers and fast forward through my explanation that I'm about to give right now. Otherwise, stick with me. We could be codependent together on this one. Number 3, log base 3 of 9 is equal to 2. The base was 3, so I'm going to raise this to the third. I'm going to exponentiate to the third. And these cancel out yet again, and I have 9 is equal to 3 squared. It's the truth. Exponential form, I should see an exponent, and I do. So for the next one, here's my base is 14, so I'm going to exponentiate to my 14, and these cancel out, and 1 is equal to 14 to the 0 power. Anything to the 0 power is equal to 1, so I'm feeling pretty good about that. I'm knowing that I'm right. That's it, except I do need a box. Feeling good? I hope so, because this is as good as it gets. Let's try another one. So evaluate the logarithm without using a calculator. Without using a calculator. What does that mean? That means I don't want you to use a calculator. So if you have log base b of y equals, another way to think about this is log base b of y is equal to, it's the same thing as saying b to what power gives you y. I've taught it like that before in the past, and I don't feel like it's as helpful. So here's what I'm going to show you, and I think it's going to make your life a little bit easier. Log base 5 of 25. I want to know what that is. I don't know what it is. So what we usually use when we don't know something is the variable x. We don't know, so we're going to figure it out. So if you were to pretend like this was not here, you're looking at the base 5. Base 5. So what I want us to do is exponentiate right now. So this is 5, and this is 5. So these cancel out, which is delightful, and I have 25 is equal to 5 to the x. And you're liking this problem right about now because you're thinking about 25 and you're looking at 5, then you're looking at 25 again, then you're looking at 5, and you're thinking, hey, 5 squared is equal to 25. So what would x have to be? 2. If I missed you, 5 squared is 25, so 2 is equal to x. You can put a box around that one because it's the truth. So back to this question part of it, it's like saying 5 to what power equals 25? 5 to what power equals 25? It's just easier for us to typically wrap our minds around it if we write it out like this. So same thing you did before. I'm going to set this equal to x because we don't know what it is. And I'm going to exponentiate. So this cancels out. This is the only solid one I did. That's going to mess with some of your heads. 2 is equal to 1/2 to the x power. 1/2 to the x power. So I'm looking at this, and I'm looking at this, and I'm thinking, okay, this is not the same because this is 2. Some of you that are addicted to decimals, you're thinking, this is like 0.5. How does that work? Leave it as 1/2. Think back, if you would please, to the last slide that we just completed. When we were trying to go from 1/3 to 3, 1/3 to 3, we needed an exponent that was negative. That's because the negative exponents give me the reciprocal. They do every single time. So if I'm looking at this, I'm trying to figure out, okay, well, 2 to what power? Well, first I need to make this 2 look like this. And so this is like having 1/2 to what power equals 1/2 to the x? Well, -1 will give me the reciprocal. So x is equal to -1. Tell you, look at that a couple, 2, 3 times. If you need to, press rewind and look at it again, because this is the only thing, I promise you, this is the hardest thing about all of these, is when you have to flip it. And I'm going to tell you, if you have to go from a whole number to a fraction, or a fraction to a whole number, think about putting a negative number here, and that's going to make your life about 1,000,000 times easier. Again, if you have a fraction, go ahead and change it into a mixed number. Go ahead and press pause while I answer that phone call, because I think it's my grandma, and try 6 and 7. Thank you. Okie dokie. So you got 64 is equal to 4 to the x after you exponentiated both sides, and you have to ask yourself the question, 64 is equal to 4 to what power? So 4 to what power gives you 64? And this is the power of 3's that I asked you to memorize a little bit ago. So x would be 3, because 4 to the third power gives you 64. And that's your final answer. Now, it does say without using a calculator to evaluate, but you can check it in the calculator. You can just type in 4 to the third just to make sure it's 64 if you weren't sure about that. Okay, last example. This is equal to x, so you're going to exponentiate to the power of 7, or to the base of 7. These cancel out, and I have 1 is equal to 7 to the x. So 7 to what power gives you 1? 7 to what power gives you 1? If you said 0, you are correct. There you go. That is your introduction to logarithms. Not too much information all at once, just because it's an intro. I want you guys to be friends once you get more acquainted. So if you're feeling like there's something around this corner, yeah, but because we're laying the solid foundation, I feel like you're going to be ready for it. One reminder, you will have a quiz tomorrow on 7.1 to 7.3. The material that you are learning today is not going to be on that quiz. It should be pretty nice and somewhat user-friendly. So be ready for that tomorrow. What else you need to know? I think that's about it. Thanks a bunch for your patience and all that other good stuff. Talk to you all soon. Bye-bye.